All right, let's get right into it. Welcome everyone to today's Explainer. Today, we are conquering a very specific and honestly incredibly crucial part of the Cambridge Information Technology 9626 syllabus. We're zeroing in on Section 3.1, Uses of Monitoring. Now, specifically, we're talking about environmental monitoring, water pollution, and weather stations. If you're preparing for this exam, you already know this material can be incredibly data heavy. It's dense, but look, today we are absolutely not just reviewing basic facts. You already know the basics. Instead, we are looking directly into the examiner's playbook to understand exactly how to secure those top-tier marks. We're going to treat your exam strategy today like a Formula One pit crew treats a pit stop. Every single second counts, every action needs to be deliberate, and there is zero room for wasted energy. Let's optimize your approach. Here is our structured journey for today's explainer. We've got 5 main pit stops. First, the challenge. Second, core principles. Third, the procedural framework. Fourth, examiner mornings. And finally, number 5, the evaluation strategy. Let's hit the DAS. Section 1, the challenge. It is time to stop losing easy marks. I have to be completely honest with you here. Many well-prepared students end up losing incredibly easy marks on Section 3.1. And you know what the most frustrating part is? The questions often seem totally straightforward at first glance. You sit down, you look at the paper, and you think, oh, it's just a question about monitoring a river or setting up a weather station, right? I know this. Wrong. The way you are expected to handle and manipulate this information is exactly where the trap lies. So, I want to pose this critical question to you right now, and really think about it. Why do students find applying concepts to unfamiliar contexts so incredibly hard? Well, transitioning from just memorizing raw textbook facts to actually analyzing a complex real-world scenario, like, say, a sudden unpredictable water pollution alert in a specific river basin, that is exactly where the friction happens. It's one thing to know how a remote sensor mathematically works. It's another thing entirely to explain how an entire distributed network of those sensors detects a chemical spill, processes that data, and triggers an automated response in a completely new environment you've never studied before. And before we continue and really break down how to fix this, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. So let's look at the reality of the grading scale. There is an exact unforgiving dividing line between a passing grade and a top-tier score on these papers. Generic rote memorization, yeah, that might get you a few baseline marks. It proves you read the book. But the Cambridge syllabus explicitly emphasizes that top-performing students exhibit connected, conceptual understanding that they can fluidly transfer to brand new, totally unfamiliar contexts. You literally have to take the foundational theory and confidently map it onto whatever wild, specific scenario the examiner throws at you. You can't just give a textbook definition of a weather station. You have to explain how that specific weather station functions on the side of a snowy mountain based on the data they just handed you. Moving on to Section 2, Core Theoretical Principles. We absolutely need to build a rock-solid foundation first, so that no matter what crazy scenario appears on your exam paper, you have the underlying theory to support a top-tier, bulletproof answer. And here is a massive, game-changing insight pulled directly from the Cambridge Principal Examiner reports. They explicitly state, candidates referencing cross-topic connections achieve significantly higher marks. Let that sink in. This is your absolute secret weapon. When you're writing about environmental monitoring, do not just stay isolated in the Section 3.1 bubble. Examiners love it. I mean, they absolutely eat it up when you show the bigger picture. How does the data transmission actually work from those remote sensors? What are the network security implications of sending critical weather station data over a public network? How is the database structured to hold years of climate data? Linking your answers to other syllabus areas proves to the examiner that you truly understand the entire IT ecosystem, not just one isolated chapter. So the crucial point to remember is that the theoretical architecture of this specific section rests on 5 core pillars. Think of these as your structural supports. First, you need precise definitions. You have to use the correct professional vocabulary. Don't call it a thing that checks water, call it a submersible turbidity sensor. Second, you need to identify causal relationships. This is huge. For example, you need to explain how heavy rainfall upstream directly causes a spike in turbidity data in a river sensor downstream. Cause and effect. Third, you need that cross-topic integration we literally just talked about. Pull in networking, pull in security, pull in hardware. Fourth, systematic analysis. You can't just jump to the conclusion. You have to walk the examiner through your thought process step by step. And finally, the 5th pillar, evidence-based reasoning. Every claim you make in your answer must be backed up by the data provided in the exam prompt. These 5 pillars directly target the core assessment objectives: your knowledge, your ability to apply that knowledge, and your high-level analytical skills. All right, section 3, the procedural framework. Knowing the theory is great, right? But how do we actually write the perfect answer when that clock is ticking down and the pressure is on? This is where our pit crew strategy really comes into play. Whenever you face a heavy environmental monitoring question, you need to execute this exact 5-step procedural sequence. Step 1, deconstruct the question. What are the actual command words? Are they asking you to evaluate, describe, or analyze? Those mean very different things. Step 2, extract the relevant data from the scenario. Filter out the noise and find the numbers or the specific environmental conditions that actually matter. Step 3, select your analytical framework. How are you going to structure your argument? Step 4, execute your analysis with very clear notation. And Step 5, present your final answer using the correct subject-specific terminology. If you treat this like a standardized high-speed procedural sequence, you ensure a complete, structured, and high-scoring answer every single time you sit down to write. Now, stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's talk about how your answer actually looks on the page, because strict presentation conventions are absolutely mandatory. If you are interpreting a massive block of data from a weather station or a network of water pollution sensors, examiners explicitly expect proper and logical headings. They want correct terminology, again, no slang, no vague descriptions. They demand appropriate data formats, so if you're synthesizing data, you should be using tables or graphs if applicable, rather than just writing a messy paragraph of numbers. And they want clear annotation that explains your findings. You literally cannot just dump raw numbers onto the page and expect the examiner to figure out what you mean. Your data interpretation skills must be showcased clearly, logically, and professionally. Make it incredibly easy for the examiner to give you points. Which brings us to section 4, avoiding examiner pitfalls. Okay, I need you to pay very close attention here. These are the exact places where past students have stumbled, crashed, and burned. This is pulled directly from the principal examiner reports, meaning this is exactly what the people grading your papers are complaining about year after year. Mistake number 1, confusing cause and effect. This happens all the time in environmental monitoring. Did the sudden temperature drop cause the sensor anomaly, or did a mechanical sensor failure cause an inaccurate temperature reading to be logged? You have to be incredibly precise about what is causing what. Mistake number 2, forgetting to check format and presentation. We just covered how vital that is. A messy answer is a low-scoring answer. But mistake number 3 is absolutely the most dangerous pitfall of all, providing generic answers. Look, if the exam asks you about a very specific water pollution scenario involving, say, agricultural runoff affecting pH levels in a local freshwater river, do not give a generic textbook answer about how ocean monitoring buoys work. It's totally irrelevant. You must apply your knowledge to the specific context provided in the prompt. And this danger brilliantly illustrates why you need to adopt what we call the method mark strategy. This is the practice of showing all of your systematic working and your logical processes on the page. Listen to me carefully. Even if your final calculation is wrong or your ultimate conclusion is slightly off base, Cambridge examiners can and will award you method marks just for showing a logical, systematic, analytical journey. Show your working. It is literally a mathematical safety net. It can save your entire grade if you make a silly minor slip-up at the very end of a 12-mark question. Don't keep the logic in your head. Put it on the paper. Before we move to the final, most important section, here is a quick, actionable study tip for you. The terminology for environmental monitoring systems can be incredibly dense, right? There are so many specific terms. To beat this, create a mnemonic using the first letters of the key terms. For instance, think of sensors send signals to remember the primary data logging steps. It's a super simple memory hack, but what it does is it frees up your cognitive brain power during the stressful exam environment. You don't want to waste time trying to remember a vocabulary word when you should be spending that time analyzing the data. All right, the final lap. Section 5, the evaluation strategy. This section right here is where we focus on the critical analysis skills that separate the absolute highest scoring candidates from the rest of the pack. To master these highly unpredictable IT scenarios, you need to internalize the deconstruct, solve, evaluate loop. First, identify the given information in the prompt. Next, break the complex problem into smaller, logical steps. Then, solve it systematically, showing your work. But here is the kicker. Don't stop there. Step 4 is absolutely vital. Check your answer for reasonableness. Does this data output actually make sense for a physical weather station? If your math says the river temperature is boiling, you probably made a mistake. And finally, step 5. Make justified recommendations based on your analysis. Don't just point out the problem, propose an IT-based solution. Because at the end of the day, top-scoring candidates demonstrate true evaluative thinking. They don't just take the data at face value. They question assumptions. What if the sensor is miscalibrated? They consider different perspectives. How does this data affect local businesses versus environmental agencies? Examiners are absolutely desperate to see evidence-based decisions and justified recommendations from you. They do not just want you to regurgitate a data table. They want you to act like a real, high-level IT professional who is actively evaluating a live environmental monitoring system. Now listen up. Students who implement these exact strategies see an average improvement of 2 whole grade boundaries, but that only happens if they practice consistently with our weekly explainers. Here is your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by without having the ultimate strategy in your back pocket. So, here is your challenge for today. Your immediate next step is to take this exact playbook, specifically that deconstruct, solve, evaluate loop we just walked through, and apply it to a Section 3.1 past paper today, literally right after this explainer ends. Don't wait until tomorrow. Find a past paper question on water pollution or automated weather stations and force yourself to plan the answer using the structural pillars we've discussed. Ask yourself honestly, are you just memorizing facts, or are you truly building a cross-topic, conceptual understanding that can survive absolutely any scenario the examiner throws your way? Before you go, drop a comment below with your target grade for information technology and the biggest challenge you're currently facing with this syllabus. Our team responds to every single comment. Like and share this explainer with a study partner so you can both level up. Ace the Exams, your Cambridge success starts here. Good luck, stay incredibly focused, and keep learning.